Today we are going to solve the problem 2.40 of Griffith third edition Introduction to Quantum Mechanics. The problem 2.40 is a particle of mass m in the harmonic oscillator potential starts out in the state, that is initial state, at time t equal to 0. Psi of x and 0 is equal to a multiplied by 1 minus 2 square root of m omega over h cross x multiplied by this whole square multiplied by e power minus m omega uh, over 2h cross x square. So here for some constant a, this is normalization constant, determine the a and coefficients cn in the expansion of this state in terms of stationary state of the harmonic oscillator. So first we will determine the value of a. The given wave function is a multiplied by 1 minus 2 square root of m omega over h cross x whole x power whole squared e power minus m omega h cross x squared. So here I am going to make some standard substitute. Let this one is z. So I have mentioned here z is equal to square root of m omega h cross x. So here you can see this will be z squared actually. M omega h is this, you take except this 2 m omega over h cross x squared is z squared. So this can be rewritten as a multiplied by 1 minus 2z is whole squared e power minus z squared x z squared by 2. So I can square it, then I will get a 1 plus 4z squared minus 4z e power minus c squared over 2. This is the wave function after the expansion. I got it. We will simplify this. So we got this wave function psi of x0 is equal to a multiplied by 1 plus 4z squared minus 4z e power minus z squared over 2. So this is the uh, wave function, total wave function at the initial condition we got. And the psi of n can be found using this relation is given in Griffith. Actually they have derived this, so that is from equation 2.86 of Griffith third edition. Psi n of x is equal to m omega over pi h cross whole power 1 over 4. This, remember that we have seen in the case of the normalization constant for ground state energy level of the harmonic oscillator, and this multiplied by 1 over square root of 2 power n factorial hn of z e power minus z squared by 2. So this hn is the nth level Hermite polynomial. I have given first three Hermite polynomial here. So now you can see, you remember that in example I have given the lecture, that is example 2.4 of Griffith. We have seen the ground state wave function as this given here. So we will verify that using this analytical method. This I have we have derived using the annihilation and the creation operator. Now we will see, we will derive the same thing within no time using this Hermite polynomial. So first we will find the ground state wave function psi naught, that is n equal to 0. So when n equal to 0, what will happen to this? There is no n here, and every time instead of writing this, we can say this is, we can define this as alpha, this as alpha. So I have taken this as alpha. Then n is 0, 2 power 0 is 1, 0 factorial is also 1. This will become 1. So Hudson of z, that is h naught is equal to 1. This is also 1. So the entire thing will become 1. So alpha, there is no n. So alpha I am taking as it is. Then this exponential term. You can compare this and this. So this is your alpha. This multiplication factor is your alpha. This exponential augment of this exponential is z squared by 2. So exactly you are getting the value of psi naught, what you got from the annihilation creation operator, ladder operator method. Similarly, psi 1, you take alpha as it is. Then 1 over square root 2 power n, n is 1. So this will become 2, and n factorial is 1. So this is 1 over square root 2. H1 of z, h1 equal to 2z. So I am writing, I am taking this 2z, and of course then the exponential term. Here I can cancel this square root 2 and 2, which will become square root 2. So this can be rewritten as square root 2 alpha z e power minus z squared 2. This is also exactly what we got in example 2.4 using ladder operator method. And what about psi 2? Psi 2, that is n is equal to 2, alpha you take as it is. Then when n equal to 2, 2 squared, if you take outside of the square root, you will get 2. Then 2 factorial is 2. So you will get 1 over 2 square root 2. Then here Hudson, 4 z squared minus 2. I am writing this as 2 times 2 z squared minus 1. So if you multiply by 2, you will get 4 z squared minus 2. Sorry, minus 2. Now I can cancel this 2 and this 2. So I will get 1 over square root of 2 alpha, as it is I am taking alpha times 2 z squared minus 1 and this exponential term. Now we can write the total wave function in terms of the expansion coefficient, that is C naught psi naught plus C1 psi 1 plus C2 psi 2. Now you compare equal power of Z. So for C naught, you can take where C naught, there is no Z. So only alpha and exponential terms are common for all psi naught and psi 1 and psi 2. So you take alpha and alpha to the left hand side and exponential term to the right hand side. Then you compare here, this term does not contain, psi naught does not contain z. You compare this expression. So there is no c. So this can be written as c naught. Uh, Here alpha c naught and this exponential term. What about this second one? That is c1. C1 psi 1. Psi 1 I am writing. Alpha already I have taken out. So square root of 2 z and the exponential term. Exponential term I have already taken out. So square root of 2z. So this will be square root of 2z, uh, and the third one, that is psi 2. In case of psi 2, I have taken this alpha and exponential term already outside. Remaining term is 1 over square root 2. This I can separate into two part. You multiply this 2c squared divided by square root 2. So then this will become square root 2 c squared. So c2, of course you have c2 square root 2 z squared minus c2. Here if you multiply 1 by 1 over square root 2, you will get c2 1 over square root 2, then that exponential term. Now you compare equal power of z with this and this. You compare the equal power and equate it, then we will find the c0, c1, c2. So we have seen the total wave function as given in problem is equal to this one, a multiplied by 1 plus 4c squared minus 4z e power minus z squared over 2. Then we have found using the expansion coefficient, the wave function is alpha times c0 plus c1 square root of 2z plus c2 square root of 2 z squared minus c2 1 over square root of 2 e power minus c squared over 2. Now you compare equal power of z in both the equation. First you take c square. So if you take this from you first you take this one c2, here you have alpha, you leave this exponential term. So because here also you have exponential term which will get cancelled, so you have alpha, here you have alpha is here and c2 square root of 2, you have c2 square root of 2, which is equal to, here you have c squared 4a, here you have a into 4, 4a. So from which you can calculate c2 is equal to, you bring this square root 2 here, so this can be written as, that is c2 can be written as 4a divided by square root of 2 alpha. So this can be written as 4 can be written as 2 into 2. So this can be written as, so if you cancel this and this, you will get square root 2. So naturally you will get c2 is equal to 2 square root of 2a divided by this alpha. Then you compare with c. Here you have c, here you have c. So here alpha, of course you have alpha c1 square root of 2 is equal to, here you can see minus 4a, minus 4a. So using the same procedure, you will get here 4a, here minus 4a. Naturally this will be minus 2 square root of 2a divided by alpha. Then now you take this that is a coefficient without c. Without c, here you have 4 coefficient. Sorry, without c, you can see here without c only one a, and here you have c naught, you have c naught, and this one minus c2 square root of 2. So this can be written as alpha, here you have alpha c naught minus c2 1 over square root of 2, which is equal to, here you can see a. So alpha can be this alpha can go here, this can be written as, sorry, before that we will replace this c2, because there are two unknown, sorry, one unknown, c2 we know it, You replace C2. If you replace C2 as 2 square root of 2a divided by alpha, this is C2 divided by 1 over multiplied by 1 over square root 2. So square root 2 will get cancelled. You will get 2a divided by alpha. So this can be rewritten as alpha C naught minus 2a divided by alpha. We have eliminated C2 here. Then you bring alpha to the other side. So then you will get this a divided by alpha. This I can simplify this. See, C naught minus 2a divided by alpha is equal to a. A by alpha, sorry, a by alpha. So I brought this alpha here. Then C naught will be, you bring this term to the right hand side, then this will become a alpha plus 2a alpha. 2a divided by alpha. You will get 3a divided by alpha. So now we have found C1, C naught, C1 and C2. Now we will form the equation for total wave function. Now we have found C0 is C naught is equal to 3a by alpha, C1 is equal to 2 square root of 2a over alpha. Of course, there is a negative sign minus. C2 is a 2 square root of 2a over alpha. Now our aim is we have to find the normalization constant a. Then we know by the superposition principle, the modulus square of C naught to C1 and C2 must be equal to 0. Then here you can see in C naught, C1, C2, you have a divided by alpha as a common factor. So this will become a squared divided by alpha squared. Here you have 3 squared 9. 2 square root of 2 whole square is 4 into 2, 8. This also 8. Since modulus square, this negative will become positive. So totally you will get 25. This is, if you add all these things, you will get to 25. So 25 a squared 25 divided by alpha squared is equal to 1, or a squared is equal to alpha squared divided by 25. So naturally a is equal to alpha divided by 5. So we have found the value of a, normalization constant. Now section P is, in the measurement of particles energy, what result could you get and what are their probabilities? What is the expectation value of energy? These questions we have to address here. Here first we will finalize the C0, C1, C2. Now we know the value of A. So what is C0? 3A divided by alpha. So A, you know, 3 divided by alpha. A, you know, is alpha divided by 5. So alpha will get cancelled. You will get simply 3 divided by 5. Similarly here also this alpha will get cancelled, and 5 in the denominator you will get 5. So minus 2 square root of 2 divided by 5. Same is the case with the C2. You will get 2 square root of 2 divided by 5. So now we got this value for C0, C1, C2. So the probability of finding the particle at the energy state 0, ground state energy, is you take the modulus square of this expansion coefficient, which is 9 by 25. Similarly, probability of finding the particle at energies level P1, E1 is P1 is equal to modular square of this, which will become 8 divided by 25. Similarly, P2 also equal to 8 divided by 25. Then what is the energy state? 0th energy state. Nth energy state of the harmonic oscillator, which is equal to h cross omega n plus half. So if n equal to 0, you will get 1 over 2 h cross omega. If n equal to 1, then you will get E1 is equal to 3 by 2 h cross omega. If E equal to 2, n equal to 2, then 5 by 2 h cross omega. Then what is the expectation value? The expectation value of Hamiltonian is the probability multiplied by that energy level. So probability of having the energy, ground state energy, is 9 divided by 25, then that energy level of h cross omega. Similarly here 8 by 25 multiplied by 3 by 2 h cross omega, same with this. Here pi by 2 h cross omega. Here in the denominator 25 into 2, 25 into 2, 25 into 2, you will get 50, and you have h cross omega in all three terms. So you can take h cross omega divided by 50 as a common. Here you can see 9, 8 plus 3, 24, 8 into 3, 24, 8 into 5, 40. You will get this 74. So the expectation value of the Hamiltonian is equal to 73 over 50 h cross omega. This is the expectation value. Now section C is, at a later time capital T, the wave function is psi of x and t is equal to p multiplied by 1 plus 2 square root of m omega over h cross x whole square e power minus m omega over 2 h cross x square for some constant p. What is the smallest possible value of capital T? So x and t can be written as using Fourier techniques, that is equal to Cn, that is psi n, and this time factor e power I e n h cross en over h cross t. This is the definition for the time dependent wave function. So first you will take n equal to 0. So n equal to 0 means psi naught. Psi naught, you will get the coefficient for C naught is 3 divided by 5. Then n equal to 0 psi naught, then e power n over h cross. What is e power is 0? E power 0, the h cross omega. H cross omega divided by 2, because ground state energy. Then over h cross, you will get over h cross. H cross will get cancelled. So this will be En over h cross. E naught, in fact, E naught over h cross. So you will get omega divided by 2. So this is omega divided by 2. You got it. Same thing apply here. Here the wave function is C1. C1 is minus 2 square root 2 divided by 5. Then psi 1. Psi 1 e power, here you have to find the value of E1 over h cross. What is E1 over h cross? Now only we have seen E1 is 3 by 2 h cross omega divided by h cross. So h cross will get cancelled. You will get 3 omega t divided by 2. Same thing is applied here. Here you will get e power minus I 5 omega t over 2, because E2 is pi divided by 2 h cross omega. So you got it. Now you take e power minus I omega t, this outside. Then this will be 1. What will happen to this term? This term will become just I omega t, because one you are taking e power minus I omega t by 2 outside. So you will get e power I e power minus I 2 omega t divided by 2, which will be I omega t. Same thing apply here. This will become e power minus I 2 omega t. So now uh, here you can see the minus negative sign. We want to convert it into positive sign. So in order to make sum of linear combination of all the wave, so then for a minimum time period that we are taking as t, capital T, e power minus I omega capital T must be equal to minus 1 in order to make this plus. So this will be minus 1. Sorry, not this wave function. This exponential term must be equal to 1. This must be equal to 1. So e power minus I omega capital T is equal to minus 1. This will happen only if omega t is equal to pi. Because if omega t is equal to pi, e power minus I pi, what will happen? You have sin pi, cos pi is minus 1. Then plus I sin pi is 0. So this will be minus 1 when omega t equal to pi. Or t is equal to this omega you bring here, pi by omega. So the minimum value t equal to pi by omega. So this is the minimum period. So for this become plus. So here 2 omega, what is e power minus I 2 omega? This will be 2 pi, because omega t is pi, means this is 2 pi. What is e power minus 2 pi? Is plus 1. Here it is minus 1. This will be plus 1. Why we are taking pi? This will be minus 1 for odd number of pi. That is pi, 3 pi, 5 pi. But question asked is smallest possible value. Smallest possible value is pi. So we will get this time period is equal to pi divided by omega. Thank you very much for watching my video and supporting me continuously. Thank you very much.